Hi everyone, today I'm very happy to present a video in the context of the current dev challenge. I'm Adrien and I'm a French guy from New Caledonia, and today we're going to talk about gemma4 challenge and especially the most little one, as I wanted to see what I could do with as minimal effort as possible. So today I'll focus on the small size, the 2B, gemma2b, and the 2B model can be described here on a Hugging Face, and this is my constraint to work on this part only. So what's the problem? The problem I wanted to focus on was the processing of PDF for indexing and standardizing formats. Let me explain the problem. I wanted to be able to compare PDFs, the one against the others, to make reporting and more advanced indexing or those kind of things. So everything is detailed in the article. And as one of the benefits that can be expected is that at the end, we can easily compare the data injected in a relational database. So that's one of the benefits. That's not the only one, but at the end, once the data has been structured, and this will be the job of gemma4 to be, we can load it in a relational database, for example here in duckdb, and then provide the KPIs and dig further and discover all the data gems hidden in the PDF. But to access these gems, we have to make important work on the PDF. So currently, at the end, one of the benefits is that here I have a full pipeline running on GitHub, and once for all, everything you can see here is open source. So the first version consists in taking the raw PDF and transforming them in Markdown thanks to a marker PDF, so on a GitHub action, I'll show you later. And then the second part of the pipeline, standardizing Markdowns that make it possible to produce PDF, for example. So on the left, the raw marker PDF output, and on the right, the one that is post-processed thanks to gemma4 to be on Kaggle. This is what I show you during this demonstration. And also, to put in evidence the standardization, you can see that all the sections have strictly the same look and feel. So the same structure means that every section has bullets. So you can compare section. We can say that the first section will be called employer beyond a job offer. They all have the same name, at the same level, at the same index, I mean. So that's the output. This is very interesting and very powerful. Once we can work on this data, we have also the benefits that I can take the data and load it in any relational database. And for example, if you have it in a relational database, you can also then make a group by and standard analytics, which was strictly impossible at the beginning of the exercise. Enough talks. Let's see where the idea comes from. So the idea comes from the fact that here's where to find a job in New Caledonia, and I'll take this job offer and this one. So as you can see, the remark was this one. They both are PDF, but as you can see, they are not structured at all the same way. We know that most of all, they have the same kind of data they have the same goal, but, and the semantic is probably the same, but they really don't look the same. They don't have the same format. They don't have the same organization, I mean. So my first action was to create a dedicated GitHub repo in which, so here, I have daily run here, and they go to scrap the open data set here. So all that has been automated. Let me show you. So here, I'm going on this data set. I'm getting the CSV, and in the CSV I have a lot of data, including the URL of the PDF. So I'm processing all that, and at the end, here, with marker PDF, I have the markdown as exported thanks to marker PDF. Then I have a whole set of instructions to enrich the metadata. So here, what you can see here has been post-processed. Here. So all these things have been automated with marker PDF. And here is the source code. Now, what is done next is that I built a website, identical. So if I'm looking for something like DevOps, I can very easily find and share the job offer thanks to unique URL. Now, the next step, so it's done. Now we're going to gemma4. The job of this notebook, as seen here, is to use gemma4 and produce a set of data. So for now, as you can see, I'm using a GPU, and the processing takes almost 6 hours here. I'll be short. So as input, as told you, I have a CSV and the URL of the PDF. So that's what I was explaining to you. So the first thing I'm doing here, I'm getting the markdown. So I'm cloning just the source repository, and then installing transformers, etc. Then I'm getting gemma4 to be here, as shown previously, and then working on getting gemma4. Now we are ready to do the job. So the main idea here is to give a set of instructions to gemma4 to do what I want him to do. I mean, the mission here is like a genius. I'm telling here you are an expert, human resource expert, and you have here below the markdown, a job offer, and then I'm injecting the markdown I got from the GitHub repo, and then I'm telling him how to write a job offer, including the emoji, the section level, the table, and all this kind of stuff. So you see, it's very structured, and here you have profile, diplomas, professional behavior, and how to apply to the job offer. Also, I'm telling him to always respect the structure, do not invent, do not add any comments that could corrupt the output markdown, here. And that's all, I would say. Now, I'm fetching the CSV and then looping on the markdown. So what's done? I will work on preparing structured output formats. So therefore, at this step, I have all the markdown which are much cleaner. That should be much cleaner. The first thing is that I want to build the PDF thanks to pandoc. So here's the code. Then, which is very easy with pandoc. For those who don't know, pandoc is a document transformation. You can transform from any kind of document to any other kind. So exporting to PDF, exporting to EPUB, so I can read it anyway on the go. Also, and probably one of the very interesting part now, I'm also preparing a docx because docx are easy to share and manipulate. Also, I'm preparing ASCII doc exports because they are very interesting to convert. And at last, which is here, exporting to JSON with the idea that I could load it later in a database. So once all these steps have been done, and the job has been done by gemma4, I have outputs. And here is the magic. So in the output, you can see the directory with the ASCII doc documentation and the markdown. So if I open any nicely formatted markdown, I can see that they look quite nice. Indeed, much better than before. Also, I have a JSON for each job offer, very well structured. And also, I have the PDF of all the job offers. So, which is nice, is that it's very easy to browse. And if you are using third-party tools, you can load it, for example, in Notebook LM or things like that. See, like that. Like that. So in the document, in the PDF, I explain how the document was built and when. So I ran a job yesterday. And how I did the job. And then we have all the job offers. And as you can see, they always have the same structure, the same sections, which was not initially the case. And I should also have added some metadata here, title, author, creator, pandoc with LaTeX, and the title, of course. So that's one of the benefits. We've seen all these outputs, and as outputs also, I've pushed these in a dataset. So the dataset is a final store where all the data I've shown you previously are stored. So here you can see that output, and you are here. In the output, you also have the avps.json, where you have in a single file all the job offers. Now on this data set, to show off a bit the potential of what can be achieved now, except EPUB, Markdown, and that kind of things, we can use this data with a more traditional way. So now, with a very simple notebook within a very few SQL, so and a very small runtime, 37 seconds, with this dataset, I can create a database. And now things are getting very fast. So first, install duckdb, create a duckdb file, and then I just have to select to take a look at the JSONs. So as you can see in duckdb, it's very easy. I just have to from and then put the path to the JSONs, see the S, and then transform it into a data frame, a pandas data frame, and see what are the first lines. And now here we have the answer. So it's a very interesting first step, and thanks to this data and some SQL too, I can create a ready-to-use analytical view, for example, job complexity, and compute and see what are the jobs that require the most skills, for example. Which then this question, before this analytics, before this extraction of the data, was very hard to produce as is. But now, it's just a simple from SQL. And on the analytics way, we can then create charts and discover what was hidden in the data, in the PDF. And that's very exciting for me. So we're discovering that for social workers need a lot of skills and human skills. Also, we can dig further and see what are the most trendy soft skills. So, for example, the top 5 of all the current open job offers in public sector in New Caledonia is organization, availability, and easy talking, and initiative, and rigorous work. So this is the top 5. It was very hard to discover this kind of KPI before running this work. And also the 5 jobs that require the most skills. So here we are. So that's the end of the processus and of the demo. So the magic is down here. The source code is available. Now I would like to make some further works because it triggered some question by my side, and I want to keep on experimenting some things. And here are the things I would like to focus now a bit further. So add evaluation phases to see the quality of the resulting markdowns. Also try to switch to CPU mode So the notebook could be scheduled without exceeding the maximal Kaggle window. So that's a question. I'm not sure it will succeed, but I wanted to try and see if the gemma4 2b can run in such a mode and within a reasonable period of time. Maybe use give a try to gemma4b and see what's the output quality and compare both outputs. And also produce native ASCII documentation, because currently I've produced the markdowns, then transformed them into ASCII docs. So I'm lacking a lot of metadata that are not available in Markdown. So maybe giving a try to ASCII doc could produce even better results. Look, I'd like to give it a try. And maybe the most interesting one, I was wondering if if I could produce a JSON with a schema and enums and a lot of constraints, could give a better result. I mean, first, actually, I'm getting a PDF, which is transformed to marker with marker PDF into a Markdown, then to a JSON. And I'm wondering what would happen if I could give a very well JSON schema in input, then take the raw Markdown and transform it into new JSONs, and then produce clean Markdown out of it. So that's a question I'm asking, and maybe I'll give it a try further. So that's all for today, for this dev challenge, which was very interesting, very exciting for me. And maybe also one of the next step is to give it a try on small hardware and keeping to tune the data, make the data better quality, better structured, but with small and open source tools. So ideally, all this work could be run on a local hardware without having thousands and thousands of dollars to invest. So that's all for today. Thanks for your attention, and hopefully you'll like it, and let me know in the comments on the article to be released very soon, because on 24th of May the dev challenge will be over. That's all for today, and continue to have fun on DevTo. See you. Bye. Cheers.